Make sure we got audio. 3, 2, 1. Just making sure. It's a little quiet. Turn it up a little bit. Test, test, test. Hope you're doing well. It's been a while since my last live stream. I wanted to check in with you guys and share what some learnings and things I've seen since the last time I've had a live stream. We've been concentrating a little bit more on other things like hardware, and that is a little bit harder to capture in video, especially in the moment. But that's an excuse. I should be taking more videos. Let's jump into today. We're going to be talking about tips and tricks in Zephyr, more related to NCS. So if you are an NRF device user, this will apply more to you. But there's some kind of vanilla Zephyr things in there for you as well. If you haven't already, click that like button and subscribe. Stay tuned because these happen at random times. Also, for some of you that have been following or maybe are not unaware, the NRF91 Feather exists, and as of last month, it is we got the test report back, and it's CE and FCC compliant. So fantastic. That it was a big collaboration between some of the early beta testers and also Nordic. So very much thank you to everyone involved. Nordic had some input on the NPM 1300, make sure that the noise was as minimal as possible. So hey, it passed everything, so I'm okay with that. So let's talk about what's going on today. There's some things that I've done over the past 6 months that I just figured might as well help people in their journey in Zephyr. This includes kind of what's kind of the upgrade path between the two different SIPs. Zephyr is very much so well known for its multi-target abilities, so keep the same code base and build for different targets. So we'll be talking about that a little bit. One thing that I did when I was developing the new board definitions, especially for the new versions of Zephyr, as things have changed, I was like, I might as well just create some new definitions. So part of that was actually creating some static partition management kind of scripts or definitions that help with migration. So we'll get into that in a second, but you guys will know, you'll understand what I'm talking about in a second. And then also another kind of nice thing to have for NRF Connect for VS Code is CMake presets. So these allow you to, for your specific devices. So I have multiple devices that I'm building for. You can set them as you can set the targets as presets, and it makes it a little bit easier. Turn my phone down. It makes it a little bit easier to set up those presets and just go. It's good for if you have multiple people working on the same project. It kind of just unifies that part of the code. So, all right, moving on. So as I mentioned, Zephyr makes it really easy. I've done a video about this. I believe it's in the notes in the description below. It's just the information about how Zephyr makes it so much easier to create multiple targets on one code base. And one thing that we do inside is we can define code blocks that are specific to the device, and it's all compile time controlled with these board specific macros. We also, of course, big fan of the .board.conf files, so you can enable and disable particular functionality in a board definition file as well. And this is all stuff we've talked about in the past, but just kind of reiterating how important it is because it makes it so much easier for everybody. This is like, for instance, this is the N9160 board conf for a specific example, or like a battery measurement example, or an application that has battery management. The NRF9160 uses the ADC for battery measurement, whereas the 9151 uses the modem firmware for that. We drive an LED with a GPIO on the NRF9160 versus we actually have to enable the LED driver for the NPM 1300. If we're doing any type of regulator control also, that's a fancy new feature of the 9151. You need to be able to turn this on as well. This is handy for the case where you want to manage your power supply on the fly. One thing that we already kind of do is when USB is unplugged, there's some things that automatically happen. And also in the bootloader, the power is managed to make sure it's turned on for a certain amount of time. So if you have a low power application and you turn everything off immediately, it gives you a chance to recover your device if you need to. So we've already gone over the kind of functionality for everything here. The nice thing about the modem firmware battery measurement is that now on the NRF9151, the battery is directly connected, or kind of the system voltage is connected to the battery, or the battery input of the NRF9151. So that just removes a bunch of measurement circuitry that's not necessary anymore. And it just is an easy AT command, which is nice. So these are the kind of the macros I'm talking about. All these variables are generated at compile time, roughly about the same. This is for NCS, so it might be different for vanilla Zephyr, but you can see you can use any of these. So say you want to determine if you want to send some information to the cloud, say, hey, what is my board? What is my board revision? All that stuff is there. So you can actually grab these and use these in your code as need be. In this case in particular, I'm using the config board circuit dojo feather NRF9160 equals Y. That's just a Boolean yes, no. And, but you can use any of these for kind of controlling, but the Boolean ones are particularly useful for the conditional macros. Everything else is just kind of like if you want to use it in your code, but Zephyr gives you a lot of different options for that. Here's an example of that conditional compilation. We're using the defined macro, and then we're inserting the board definition as provided here before. And now this is located in your build folder. Newer versions of NCS, it's going to be your build folder, the name of the application, Zephyr, and then .config. It's a little bit different for older versions. It used to be just in the Zephyr, the build Zephyr.config. So they move things around just a little bit. But this is like, hey, we're getting an LED, single, GPIO LED. And then the other one is like, okay, we're actually pulling the LEDs driver. You can see here, we're differentiating between the two. We're just doing a quick pin toggle on the 9160. And then we're using the LED driver API here for the 9151. This is just a work queue function that gets fired however many. You can see work schedule, we're scheduling it after every 250 milliseconds. So it's a fairly quick blink. Here is an example of battery reading battery voltage for the two different devices. So for instance, the battery is set up as a sensor channel. So we're just using the sensor API for doing that. If you don't have the sensor API turned on for that, you have to make sure it won't work. Probably won't even compile. Then the NRF9151, as mentioned, uses the modem info functionality. So you need to use the modem info module for that. So there's some underlying code or modules that need to be turned on typically for all these APIs to work, and it'll barf if you don't have it turned on. So the nice thing about all of this is that when you do compile, it'll automatically select all the code that you need for that particular device. Sorts it out at compile time. If you did something wrong, it will, the compiler will barf at you. So that's the nice part. And it's a double-edged sword. It could also be a nightmare, depending on how complex your code is. But in this case, these are pretty simple. between the two boards, the NRF 9151 is just a newer 9160. So there are very little things or differences between the two devices. You can actually program a 9151 as a 9160 for the most part. There are some changes there, but and you can use the macros to control both kind of the features and the function. So functionality, where I mean is like you can use those macros to send different data to the backend, like I kind of mentioned before. So you can send the board version, the board name, 9160 versus the 9151. That way you can, that's for useful for handling like photo updates, things like that, where you know what type of, what board it is, so you can feed it the right file, because they do require, unless you do some finagling, they do require different files. So something to keep in mind. Slides. Now for the board level partition management definitions. This is really, so this is one thing that I kind of got to pretty late in the process, and I'm glad I finally did it, because it was causing a lot of issues with switching SDK versions. Every SDK version, the script that makes the partitions on the 9160 change ever so slightly. Maybe it's Nordic says, oh, we need to increase space for the bootloader. We need to increase, decrease the space. We need to change, move things around. And that's happened in like almost every version, major version of the SDK. So it made sense to just say, hey, for compatibility reasons with the built-in bootloader, we need to make sure that this is set statically, for now until the future. So this is more important for the 9160 because the bootloader is how most people load the code onto the device. For the 9151, not really a big deal, because you're using the built-in programmer, the Seamsys app that is on there, the RP2040. So for vanilla Zephyr, you could actually set these definitions as part of your DTS file. So even my boards has these definitions, but they're not really used. They're the PM static files are actually used for NCS. So for these type of boards, so something just to keep in mind. So if you're using vanilla Zephyr, you can define partitions and keep them consistent that way. But here is like these are my board definitions, kind of the structure, the different folders here. And in there, the file name is like circuit dojo _ feather _ 9151, and then pm _ static.yaml. So this is part of it. It's not really, I'm just showing you, like every little area is defined, even the areas in between the two different, the little partitions. There's like little padding and things like that. So you can see MCU boot primary and secondary. You can see the address and the size. They're all hex 78. See, you got like empty for padding, secure. You can also define the external storage, which I don't know if this one was the 9151 or the other one, but you can kind of pop everything in here, and it'll keep it consistent going forward, which is very nice. Again, for migrations to a newer SDK, you know that the partition's the same. So when you go to upgrade it using Newt Manager or one of the other utilities, MCU Manager or whatever, that there's no problem with that. So as long as the signing key is the same. No. CMake presets.json. This is one cool thing that I noticed in their documentation that was kind of handy. You can set the standard. I'm gonna do my air quotes. Standard ways to keep your build configurations the same. So I particularly like, if I have multiple targets, I like creating build folders that like build _ and then the device name. That way I know which one is which, and then you're not overwriting or blowing away one of the build folders, because everything is cached. It's a lot faster if you've already built an application. So this makes it really easy to import into NRF Connect for VS Code, and it's pretty straightforward. You have these. This is located. You can locate this CMake presets.json in the main root of your application that you're running. And then you can see here we have got a couple of presets. You got the build underscore NRF 9151 and then the 9160. You just basically say, what's my board target? If you want to target a tool chain or whatnot, you can do that there too. But that makes it really easy, so you can select the target and then just go instead of having to manually import it or write it every time. Sometimes I've seen the build configurations get messed up, and then you got to go through and delete it and re-add it. So this makes it a little bit easier. You can just click presets, 9151, done. There is a good, I think, DevZone article on this. I'm gonna write this down. I'll link to that as well. Link to DevZone. That's one thing I didn't get in the description. So if you need more details, I will provide that link. So as you saw, or how I mentioned earlier, my kind of preferences for creating those build folders, it just makes it a little bit more sane when you're building multiple targets. I've done that with the Circuit Dojo Zephyr tools extension for VS Code. That does it automatically. So if you have multiple targets, it will create those folders and those subfolders in the build folder for you automatically. So that's this CMake presets.json is kind of replicating that ability in for NCS for VS Code. So so in conclusion, that's it for today. But I just want to kind of go over these things because I found them particularly useful, in my adventures upgrading code or migrating from one device to the other, or getting the new device up and running on the same code base. So for instance, the all my samples and things all are updated. But critical for the kind of cross-board platform firmware applications. So making sure that OTA updates are sane for the partition manager, but the conditional elements is just for making code sane, where you can get everything working with the different features of each board. And then the CMake presets.json help organize your NCS application, so make it a little bit easier for setting up those build targets. And that's it. So if you haven't already, jump over to jaredwolf.com, subscribe to the email list. I do send out an email occasionally, mostly telling people, hey, there's a live stream coming, or if we have certain announcements or anything like that. And that is it. And I don't see any questions, so I do need to run, but thank you for watching. And if there are things that you'd like to see me cover on Zephyr 101, or maybe not so Zephyr related, maybe more NRF or building things, I do have some cool things coming down the road here. In particular, this is kind of cool, 3D printed. I'm gonna get it on the screen here. So you can insert a rigid LTE antenna into here. You can kind of see where it sits, and you can slide in an NRF 9151, and then on the other end you can pop in a battery with a JST connector on it, and essentially you have a little 3D printed self-enclosed tracker type enclosure. It's kind of like a stick, so I thought that was kind of cool. Still got to work through a little bit on it, but I do need to get some firmware written for it as well. But it's kind of a cool idea. I just don't know how well it's going to do in a hot car or something, because this is 3D printed plastic, so kind of a neat thing. The only thing I probably would add functionally, at least to this guy, is probably a not a bushing, but a grommet or something here to make sure that it's watertight. That's kind of the idea, is to make it as watertight and protect the electronics as possible. So, all right, that's it for now. But if you guys have any ideas, feedback, thoughts, feel free to leave them in the comments below, and I'll see you next time. Thanks for watching.